Hello again, and welcome to another episode of my interviews with embedded systems engineers. And today I have Aniebiet on the call. And Aniebiet is the person who Aniebiet is the person who Kufre trained under during his internship. And so we thought to have a chat with Aniebiet to get a sense of the embedded system space, even prior to the time when Kufri got involved. And at the end, we're also going to get his advice. So thank you for joining us, Aniebiet. And how would you introduce yourself?
Thank you very much for having me here. So, my name is Aniebiet Michael Ezekiel, and over the years, I've been longing to speak about this passion, and I'm happy I'm having this opportunity. I, I had my bachelor degree in the University of Port Harcourt, electrical electronics engineering, and I had the first glimpse of what we call programming over there. However, it was this blackboard programming where my lecturer who said I learned this in the 80s and he will write them word to word. And he hold the paper with one brown old paper with very powerful hands. And when exams comes, he expects you to write word to word on those programming 8051 he wrote on the board for you. Those were assembly language anyway. And that killed my interest completely in electronics and anything programming. In fact, my project in my undergraduate, that's my bachelor, was in electrical power. I developed a wind turbine. So my project was generation of electricity using the wind turbine because my passion for electronics or programming was completely killed. But I didn't allow it to die. After I finished, I had the opportunity to go for my master's. In fact, my degree in Uniport was poor. I call it poor because I didn't expect to get such um, um, performance. However, I couldn't help it because of the environment I found myself. And I told myself I'm going to go immediately for my master's. My parents struggled to sponsor me, and I went to the UK for my master's. And I went to study control and instrumentation. What led me to this was because my project in my bachelor, um, I used to have these burnt devices. I produce my current as expected, and I try to store them in the batteries. But when the wind increases, the rectifiers keep burning. So after a little research, I discovered you need to build a controller, something that can control that unwanted maybe energy or something, or maybe divert some. So that prompted me to go for my control and instrumentation engineering at the University of Derby, that's in UK. On arrival, there was a news that the key lecturer for this program, which is supposed to teach us maybe like the PLCs and all that, had a stroke, and in that particular year, we would not be having that course. And an elective course was embedded system and was made compulsory for everybody. And we had to start my program with embedded systems. So I had no choice than to meet it. On meeting it again, the class was quite interesting. The lecturer was passionate. So I started learning C programming for the very first time in my life. And we had to build a vehicle, an autonomous vehicle. In the process, I asked some few questions to some colleagues, which I got some embarrassing answer. And the answer was go and Google it. And as a Nigerian, I took that embarrassing answer and decided to start Googling. I Googled till the point that those same people, they came back asking me questions in that same course. At the end of the course, in embedded systems, I happened to grew a lot of passion for it. And we were using the ARM processor. The ARM embed was the controller we're using. And it was so interesting that we had a group project which was supposed to end that course. And my team, I was the leader of the team, were the central controller. We had sub processors for this project. It didn't actually end well. However, the lecturer came and said he wants somebody to take this project as a final project, as a dissertation in quotes. So everybody as well disappeared because a lot of people performed poorly in the program in that particular course. I picked up the challenge and I took that as my final project. That is how my journey of embedded systems fully began. And after the program, I came back to Nigeria. And getting to Nigeria, I discovered that this space is actually there. From there, I joined the industry back again. Before I went to the industry, I came back to the University of Port Harcourt where I studied. I met my HOD then, as in the current HOD, as at when I came back, and I told him, "Oh, I want to come in. I have something to pass to students, which I'm passionate about. I don't have this as my passion for future, but I mean, I can pass it to others. Even if I don't do anything, I know people have this knowledge." And he further killed the vision because he pushed me out from the way. But I mean, I left his office and I got back into the oil and gas industry for control and instrumentation, which I worked for 8 years. And whenever I come back, because it was an offshore project, whenever I come back home, I felt this passion I have for embedded systems should not die. So I kept investing on it. Just for an introduction, currently I am in Germany. I'm back into embedded systems fully. I'm working on a project it's called the Curate project for the medical team. It's kind of a wearable which is going to have an FPGA, and we're going to get some sensor data from the Krankenhaus at the hospitals, and we're going to train this data using probably any model we have chosen, and then we're going to deploy this into the FPGA. So I'm filling the gap of deploying the artificial neural network into the hardware back again. So that's just a rough introduction about myself. Thank you.
Well, I can say that that's probably one of the best introductions I've ever heard. And I could relate on so many levels to what you were saying when you talked about the lecturer writing on the blackboard. Yeah, I experienced that as well. So I went to study computer science in 1998, and yeah, code was written on the board. I remember the first time we had an assignment, you also had to submit the assignment on paper. And I submitted the assignment, and I think the lecturer gave me 3/10 or something like that. And I walked into his office. There were some ladies that were crowded around his table. And I said to him, "Excuse me, sir." And he looked over. I said, "You gave me 3/10." And he said, "Yes." And I'm like, "I'm supposed to get 10/10. And he was shocked. And he said, "Did you run it on a computer?" And I said, "Yes." "Get up, let's go to the lab." And he was shocked by my audacity. You know, how would a 100-level student ask a lecturer to get up? You know, but I said, "Get up, let's go to the lab." And he said, "Pass me the sheet of paper." And I passed him the sheet of paper. He looked at my face and he just changed the score to 7/10 and gave it back to me. And I said, "It's not good enough." And he said, "Just take it that way." It's interesting because while you were speaking, you know, your story reminded me of some of these videos you see where at the start of a race, you know, a child falls down, all the others take off, and you're thinking it's all over for the child. And then the child just ends up winning the race, right? I told people, I watch Formula One, and I said, one Formula One race is like life. You see people crash, they fall to the back. Sometimes they even lose 1 or 2 laps. But because there are so many laps, they have time to make up for it. It just takes patience and consistency. and they make up for it, and you see them closing the gap, passing people. And it's quite interesting. And I think that what was most important was that your spirit wasn't dampened. You just took everything in your own stride. You took advantage of things. So it's, I don't want to say it's a Nigerian spirit, but, just that ability to just grab opportunity as it comes, right? So went for control and instrumentation. One course was switched out for another course, due to circumstances beyond anybody's control. But you took it, right? You ask a question, somebody says Google it, and the next thing you've become the Google for everyone. It's really an awesome introduction, and I hope that people can see the potential in life from what you've narrated to us. It's interesting that you're in Germany now, and again, what you were saying about what you're working on makes perfect sense. Interestingly, last night, and I just tweeted about it last night, I was working on capturing inertial measurement units data from it's an Arduino Nano 33 IoT. It also has an ARM-based, it's a Cortex M0 Plus, I believe, from Microchip. It's Atmel. It's a SAM-D21. So, but I was capturing IMU data, streaming it onto a platform called Edge Impulse that automates machine learning pipelines. Again, so that I can explain it to people. So, one of the challenges with training artificial neural networks and then deploying them onto microcontrollers is that on the one hand, you need to have expertise in some language. A lot of the time it's Python, or you need to have expertise in collecting the data, feature extraction and engineering, training the network, hyperparameter tuning, deciding how many layers you're going to have and all of those things. And then when you're done with all that, you then need to carry out all of the work that is going to take that large model and shrink it down into a much smaller model. And then when you're done, you now move to the world of C and start deploying it, and then again capturing sensor data, again transforming it, and then performing your inference and stuff. But it's a wonderful world. And so I noticed that you said you're going to be using a field programmable gate array for that, as opposed to, let's say, some system on chip. What informed the decision to go that route?
Okay. Probably I'll start it from here. I have worked on the system on chip that's the microcontrollers for several years, so I have a bunch of experience on that. However, we have this lot of limitations which the microcontrollers could perform compared to the field programmable array system, that's the FPGA. And we are not looking at just a prototype, we're looking at a final product. So at the end of the day, we are going to harness a lot of resources. And if you look at the current application of inference with multiple data, you should be looking at systems that has some dependencies. So when I come to my FPGA, for example, I can map out a lot of things compared to the system on chips that a lot of things are predefined for you. So I mean, the resources I need, I can get a lot of block memory, which I can store various things at different ranges. And then I can also do some manipulations based on what I want. I have things like the multiple processor capabilities. I can run things I can leave my CPU to be doing its own job, while I can get some soft cores, put in some different activity, for example. And in this project, we are working with a lot of complications. Medical applications have a lot of complications. So the idea is, if I see someone and I don't know what happened, maybe probably the person is unconscious, I can't talk to the person. I just have to connect instrument to the person's body. So I should have something that can detect multiple complications and this should be happening in a short time, short duration. So if I'm going to use a microcontroller, for example, a system on chip, it's going to be tying down the CPU, getting one parameter after the other. But I can do some parallelism and get some things done in parallel form, whereby I can check for multiple complications in a short while, and then I go into even bringing up my data, and then the system should also have some kind of give some kind of suggestions for treatment, because you're going to have a treatment plan as well. So these parameters and this need demanded I go back into using things like the FPGA. And unfortunately, I never had skills in the FPGA before coming here. I've worked all through for the past 10 years on microcontrollers. So I needed to divert a bit so that I can harness this useful opportunity and then actually get the result needed by this project.
Okay, great. Yeah, that makes a lot of sense. There are a few projects that are coming up now. Some of them fuse Cortex A with like a Cortex M. So there are quite a number of Cortex M now are even multi-processor, but then there are some where you have like a Cortex M and a Cortex U. Actually, not called the Cortex U, but it's a neural processing unit. So there are some projects that fuse a Cortex A with a Cortex M and a Cortex, and a neural processing unit. I should share some of those resources with you. They could come in handy for future projects. So I'm thinking,
nice.
Okay, nice. So I'm thinking, let's go back to your school days, because I always like learners to get a clear sense of what they're going to be learning on and what sort of resources that they could use, right? So when you got to the UK, can you remember some of the microcontrollers that you had to learn on?
Right. Before I started training people, as soon as I got to the UK, the first microcontroller we used was the ARM Embed. And there was this book my lecturer then wrote. So ARM Embed was the first microcontroller we used, and we were to do this multi-processor networking. So we used 5 different ARM Embed on to form a project. Thereafter, there was a need to look at things like things that could have some interfaces, like the Bluetooth interface, because I also did a little project called the Blue Control, where I need to use the Bluetooth to control some home appliances. That was in 2012, yes. So I got another controller. It was not a microcontroller anywhere on its own. It was a chip with an ESP on it, with a Bluetooth interface as well. So, but majorly, what was applied throughout my study in the UK as a microcontroller was the ARM Embed.
Okay, that's interesting. That's interesting because I also believe that the embed platform is huge. Quite a number of boards use it. In fact, the Arduino team adopted the embed for the Arduino Nano 33 BLE, which is what Harvard and Google ended up using for their tiny machine learning course. Unfortunately, it's sold out at the moment, but the Nano 33 IoT is a close second. It's not exactly an embed device, but it works. It has the IMU that I was playing around with yesterday. Okay, yeah.
Okay, so just to cut in, that particular controller, the beauty of it was that it had this cloud kind of online compiler. So you didn't have to install anything. And we usually use this name rapid prototyping. I mean, just carry a controller, the microcontroller, reach anywhere, just connect your USB. You don't have to install any driver. I mean, just open the cloud, log into your compiler, and then start programming. So it was quite an interesting one. And that was what motivated us to most of the tasks that we use the ARM for, that's embed. But much later, when I came back to Nigeria, I came with I think two of that device. I bought personal one too, came back. And when the training phase began, I'm sure we'll talk about that later much more. I needed to get more separate controllers because I needed my students to have a feel of different things and to understand how different controllers work, and also to make them understand why do we choose different controllers. So that actually took me to getting the Arduino. Started with the Arduino Uno, went to the Nano, then went to Raspberry Pi and to the Orange Pi and all that. So we now later got explored opportunity to explore several other microcontrollers, including the PIC, of course.
That's great. And I like the fact that you mentioned the online compiler. So the embed, they've had that. They're also introducing something called Kyle Studio, which is also online. Yeah, it's a much newer variant that I think people are going to enjoy. I'm looking forward to one or two courses coming out that specifically focus on Kyle Studio. The thing about Kyle Studio is if you even check it out now, and I will put up the URL, but it's KEIL. That's the spelling. When you check it out now, you'll find a number of Embed OS boards that are supported there. So you have boards from ST Microelectronics, I believe boards from Texas Instruments, a whole number of development boards are supported. And interestingly, so you answered the question I was going to ask about what IDE you were using back then. So you just, you jumped the gun and answered that. So
right.
Yeah, let's talk about your training phase. So I know that unfortunately the university gig didn't work out, and I think that you'd have been a splendid lecturer. Being able to say, here's what didn't work for me, here's what worked for me, here are the challenges I had. That brown paper and the blackboard would have disappeared. Yeah, but I think as Nigerians would say, we move, right? So every disappointment is a blessing. So you end up outside training people. Tell us about that.
Okay, so October 2012, 2013 rather, I finished my master's. So that was when I came back to Nigeria, and I think that same month I met this lecturer I mentioned earlier. So thereafter, I had another interview in Lagos. So I traveled to Lagos. In this short period, I had a presentation at NIEEE, that's the National Institution of Electrical Electronics Engineering. And some students were there. I think the SEAS, which is the Society of Electrical Engineering Students of Uniport, the president was in that meeting. So he got my contact, and then he invited me for a speech in the SEAS conference, I think so, for that year. So I went for that conference, and I spoke to students, which is one of my passion. And I also introduced them to some concepts I mentioned earlier. I introduced them to even I think I did a video, the video of the vehicle I built. So, and I explained how it works, and I explained what embedded systems has been. And it actually took over the arena. And after the speech, the same lecturer I mentioned came to meet me, that's the HOD. And like, you students, when you people go and actually get some skills, you don't come back. He had forgotten that he's the same person that I've met him some time ago. So when students met me, I felt this passion I have and this knowledge and skill I've developed, I have to pass it across to people. How do I do this? And the majority of them kept contacting me. Please, we want to learn this. We want to learn this. So I decided to form a company then called Aniebiet Automations Limited. That was in February 2014. That's like 3 months later. Registered the company, and I took the office at Choba, which is very close to the students. And I made it such a way that it could be very affordable, that students could come in. In fact, some students didn't even have the fund to pay for the little training. Some of them, I had to like bring them in and give them maybe some tasks to perform, maybe projects, and raise some things that could actually give them the skill. So Aniebiet Automation began with training students and also consultation for projects. The same lecturer I mentioned, he got to know about this company, and he came Nicodemously one of the days to see me, and also solicited that we have to partner. So he will want to send students to come learn and do projects. Although I had a philosophy that I don't do project for students. Anybody that is coming, the first thing is you must learn, and then you do your project. So I think that didn't go well with him in some cases, because sometimes he may ask me to write report. I say, sorry, I don't do that. The students learn, students perform the project, and the students write the report. My own is to look at what you have written and then do some professionalism on it. So that is how training began. And I trained a number of students. In fact, two of them are already in the UK doing some things on hardware. And Kufebong, you mentioned, is one of them. We have Kuro Jeremiah, we have Antonius Chidozie, and many others. I can't even remember their names again. So I didn't get fund much then. I approached my father. I told him, I want to do this. My mother was against it. He said, no, my son will not suffer. You can't come and start struggling as an entrepreneur. But after the discussion, I met my father again. I said, see, I want to buy components. Components are actually expensive. I need to get the PSU, the power supply unit. I need to get the oscilloscope. I need to get electronics. I need to get sensors and actuators. And I started robotics. I need to get some robot arms and servos and all that. So he saw my passion and he decided to give me, I think it was ₦1 million he gave me then, which I used and bought a number of components to kit up the lab for practical, because I can't just be teaching something without having a practical feel of it. So that's actually how the journey began. And I started training students, and they came, majorly, most of them came for IT. Then later on, some came for advanced training. I had some people coming all the way from UK even. My lecturer over there, I was actually telling people about me. So some Nigerians that go to do courses, he will refer them, they come for training. Other people also coming from places like Warri, and some contacted me from Lagos, probably because of distance. We couldn't actually do some hands-on training with them. Some had to like get some starter kits and post it to them for them to, also have a feel of the hardware. Then later on, we entered into online e-learning, where we can post it to you, and then we have all the resources online. You can now do some work. We can give you some projects and all that. That's actually how the training phase went. In Nigeria, actually, the career opportunity was very slim back then. However, my view for this space was you can be an entrepreneur, you can actually develop things. I told them in my house, everything is automated, I automate them. And I met a few persons. Yes, we couldn't have a lot of way we can actually make this aesthetics design, but I convinced some customers, some clients, because we still do projects we give to clients that, see, it may not be so beautiful, we're going to box it up, but it's going to perform what you want it to perform. If you want to buy it outside, it may not have the features you want. So some were convinced, and we were able to perform the project as well. So that's actually how the training phase went.
Interesting. So that online learning component, is it still up?
Yes, it's still up. As at few months ago, actually, because of some reasons, I left the Choba branch and I trained someone who took over the Choba branch. We had another branch again back still in Port Harcourt. That's the Rumukushi branch. I also left left there, trained somebody to take over from there because I had to also face some things. Like I mentioned, I'm this multiple discipline person. So I also work in the oil and gas as a trainer, also in instrumentation and electrical and control system. So I had to make things move, and so the online system is still there. If you go to automations.com/e-learning, the platform is still ongoing. However, I was managing that personally because I feel the passion I have for hands-on, I can enforce it. So the people, I don't want to leave it to someone who will like, okay, just come and learn. The person doesn't have a feel of the hands-on. And the certificates we issued was based on this. The project must be delivered. So for now, the e-platform is on. However, there are some restrictions in who to register. The majority of our trainees now, we ask them, please come to the office so that we can manage that space with the trainers we have currently.
Okay, great. So I know we've been on for 48 minutes now, and you're in Germany. You're probably going to go back to the office at some point in time. So, is there anything you want to talk about that I haven't asked?
Right. Generally, the space in Nigeria, what are we doing in Nigeria for this? As a person, I didn't want to leave my country. It might interest you. When, in fact, I was given a PhD position after my master's because of my performance. Although for some other reasons, I was not happy because this segregation was still there. Imagine I was the best student for the postgraduate and I was not given any award for the first time in that particular year. There was no award for the best postgraduate student. So I felt, no, let me go back to my country and whatever I can add, whatever I can influence, whatever I can introduce, I do in my little space. So my advice is we should still have that passion to still do something in our home country, no matter how little it is. The space, it might take a while. The software is already getting the grounds, so I don't know why hardware shouldn't. I mean, it's the we may have some difficulties and some challenges, like we mentioned. We don't have any companies or any manufacturing plants for any even as little as a resistor. I mean, in as much as we don't have all these resources, does not mean that the vision should completely die. I think my advice out there is the 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 hardware space is still very, very much needed. There is still a lot of open floor for that in every part of the world. In fact, we are actually just to introduce, trying to bring what we call the embedded AI into Nigeria as a partnership program between Europe and Nigeria, which is quite an interesting one because it's going to bridge a lot of gaps. And I'm sure investors also will be looking at, okay, can we also turn into manufacturing some things for them to use if we have a number of people out there? So the hardware space is quite interesting, and I want to tell my fellow Nigerians, please come into it. Don't be afraid of how will you survive. I mean, as a person, I can give you my testimony. I was in Nigeria for the past 10 years before I came into Germany, and I actually excelled in a number of ways, even in the hardware space, with the little resources I could get. So I'm sure that there is still opportunity out there, and excellence will still come if the passion is there. I mean, we still go further and further.
Okay, thank you for that. Now, advice about learning. So, what should people bear in mind while they're learning?
The, at the start, learning controllers like Arduino could be very easy. I mean, you could actually play along with it in a very short while. You can actually get some skills. However, that may not be a very good platform because there are a lot of limitations you definitely face. Things like Raspberry Pi could be very interesting to you. So what I'll generally say is start somewhere. It might be the easier one, but don't stay there. Keep moving because the space we are currently is actually a moving space. I did mention how I've been on microcontrollers for the past 10 years, and now I'm moving to I've been on the SoC, and now I'm moving directly to the field programmable gate arrays, which of course I can see that there's a need to actually bridge some gaps in the AI world in that particular field. So start from somewhere where your reach can be, and then keep making some progress, keep looking at what is available, what has been introduced, and then make progress from there. That's just my advice. The C programming is actually a key one. The Python, of course, is coming to take over almost 90% of what we are doing because you must interface. And then now we are working also on the HDL, that's the hardware description language. So, but the starting point is most important. Understand how they work, what components are there, what's your input and output, and what is my middle platform, what my controller doing. If you understand that field, then you can make progress in that. I'll also say there are a lot of resources out there as well. Not everything is being paid. Like I mentioned, I was challenged by the word, go and Google it. I mean, and so I will still challenge people, go and make some research. There are a lot of resources. I've mentioned that we have started an e-learning platform. We have many other e-learning platforms already, things like the Udemy and the Coursera and all that. You can still get a number of things without even being taught. But for hardware, you will need some hardware. That's why it is hardware. So you can sacrifice some little funds and get the hardware and play around with things and then see how it works. And before you know, you make a lot of progress. Thank you.
So thank you so much, Aniebiet. You are a world of knowledge, and I'm sure you know that I'm going to be reaching out to you from time to time to come and talk to the ecosystem as we build it. But I want to say a very big thank you for the time that you've given to us. I know it's a huge sacrifice. So thank you and enjoy the rest of your day.
Thank you very much. I appreciate it.